So the point of these questions was to find where it's increasing and decreasing in the max and mins. So that's all the first derivative stuff. So we're going to find the first derivative. All right. What we really want to know is where is that 0, because we really want to know what's positive and negative. So we need to factor this. So we can take a 2 out. So we need to factor that quadratic or do the quadratic formula. We just need to know where's it equal 0. That's what we're looking for. So to see if it factors, we're going to do 3 times negative 10. That's 3 times negative 10. It's negative 30. And we need two numbers that multiply to negative 30, but add to 1. That's this coefficient of x right here. And that's going to be 6 and negative 5. So that means this is 2. We're going to split up this into plus 6x plus negative 5x. We're going to group these two together. We're going to group these two together. And then we're going to factor out what we can. So from the first set of parentheses, we can take out a 3x, leaving us with an x plus 2. From the second set of parentheses, we can take out a negative 5, leaving us with an x plus 2. And that 2 is just hanging out up front. Don't let him bother you. That means there's an x plus 2 here, and then a 3x minus 5. So our critical values for f prime are negative 2 and 5/3. So we are going to make a number line with those numbers. Let's get you a little bit bigger here so we can see that. Okay. So we're going to have negative 2 and 5/3, which is coming from right down here. And this is my number line for f prime. So I'm going to check the sign of f prime in those intervals. Okay? So a number that's down here could be like, I don't know, negative 8. Plug negative 8 into the derivative, which you can plug into here, but I like to plug into the factored version. If you plug negative 8 into there, you're going to get 2 times negative 6 times negative 29. But all that really matters is the positive number times a negative number times a negative number. That's a positive. That means f prime is positive that entire time, which tells me f is increasing. The number in my second interval here is 0. If you plug 0 into the factored derivative, okay, or the original derivative, doesn't matter, just plug in 0 to one of them, to f prime, not f, but you would get 2, which is positive, times 2, which is positive, times negative 5, which is negative. That means f prime is negative in there. It means we're decreasing. And a number bigger than 5/3 could be like 10. If you plug in 10, you're going to get 2, which is positive, 12, which is positive, and 25, right, which is positive. Either way, positive. All right, so all that means is that f is increasing from negative infinity to negative 2, union with 5/3 to infinity. We're just taking the intervals off that number line. It's decreasing from negative 2 to 5/3. There's a relative max when it changes from increasing to decreasing. So this is what this tells me this graph is doing. It's increasing, decreasing, increasing. This point here is negative 2 something. This point here is 5/3 something. Okay? And I hope that makes sense too, because it's a cubic. So you see it goes up, down, up. That's what cubics do. Well, some cubics do. But anyway, the relative max, sometimes they just ask for the x value. That's negative 2. But if you want to find the y value, you got to actually plug it in. So it's actually negative 2, comma, and you'll plug negative 2 into here. If you do that, you get negative 16 plus 4 plus 40 plus 1. What's that, 44? Hold on here, I confused myself. 45, take away 16. Is that 29? So 29. So that's this point right here. The relative min happens when x is 5/3. But if they want the point, you just plug y into the original function, or x into the original function to find y. And that's kind of a pain in the butt because you got this 5/3. But if you cube that, you get 125 over 27 times 2. It's 250 over 27. Let me write that a little better. Yeah, I'm just plugging in 5/3 into f to see what the y value is there. So it's 250 over 27 plus 25/3 squared. Nope, 5/3 squared. It's 25/9 minus 5/3 there is minus 100/3 plus 1. And the common denominator is what, 27? So this is a pain. So that's going to be 250 over 27. You got to multiply that by 3, so that's 75. Got to multiply that by 9, so that's 900. You got to multiply that by 27. So that's this number here, whatever that happens to be. That's 325, 352 minus 900. So let's take us down to 600, 548. There we go. I might have messed that up, but you're just plugging it in. It's negative. All right. But most of the time, they just want the max and the min, the x values here. So that would probably suffice for that. All right. Let's try number 2. Okay. Same thing, we want increasing, decreasing, all that good stuff. And that's what the derivative number line tells us. So we find the derivative and make a number line. So h prime of x is 4x cubed minus 32. I need to know where is that 0. So we factor it. Get that. And you can factor that if you want. That's a 3 there, by the way. Or you can just, we just need x cubed minus 8 to be 0. That's going to happen when x, if you saw it, add 8, take the cube root. Just 2. 2 is the only number on that number line. Okay, so we make our h prime number line. We put 2 on there. Something to remember, if 2 came from h prime, which it did, right? Then that's what I'm checking in this interval, in these intervals. So when I plug a number here like 0, you don't plug 0 into h. We're checking at h prime. That's why I put this h prime out here. If you plug 0 into h prime, you're going to get a negative value here, which means decreasing. If you plug a number into this interval, 10, you're going to get a positive value in h prime. So that means we're increasing. So that means h is increasing from 2 to infinity. It's decreasing from negative infinity to 2. And there's a relative max nowhere. And there's a relative min at 2, comma. Again, it might just ask for the x value. I'm finding the y value just because. But you plug 2 in, you get 16 minus 64 plus 4. That's 20 minus 64. That's negative 44. All right. So that's what we know about that 4th degree equation. And while we're here, let's do the next couple too. So the basic rules are always the same. It's the algebra that gets a little hairy. So if you're trying number 3, again, some of these are a little nasty here. I'm going to walk through this with you up here if you want to pay attention. But the steps are always the same. You got to find the derivative and find out where it's 0. So k prime of x, because this is x cubed minus 9x to the 1/3, the derivative of that is 1/3 x cubed minus 9x to the negative 2/3 times the derivative of the inside, which is that. All right, and I need to know where is that 0 and where is it undefined. And that looks like a mess, right? We're not super happy about this. But to find out where k prime is 0, I just need the top to be 0. Okay? So you can factor that or solve it. You take out a 3, you get x squared minus 3 left in here. But that factors into x minus root 3 and x plus root 3. So the answers we get to that are plus and minus square root 3. Okay? But then we can also find where's k prime undefined, because it's a fraction, and that's just me setting the denominator equal to 0. Well, it turns out the only way for that to be 0, so 3, we're multiplying by 3, right? That doesn't matter, is if the inside is 0. Like we need that to be 0. So we factor that, take out an x, you're going to get this, and that factors nicely. So the zeros coming out of there are 0 and plus and minus 3. So for this one, sadly, we actually have 5 things to check. All right, we're going to put them in order. We have negative 3, we have negative root 3, we have 0, we have root 3, and we have 3. We got to check all these intervals here because this function's a little bit weird. Keep in mind, root 3, I don't know if you know this, is about 1.8, 1.7. You should know it's between 1 and 2 at least. Okay? So a number that's down in this interval here could be like negative 8. Really doesn't matter. If I pick a number back here, negative 8, and I'm plugging it into the derivative. Okay? And we could factor this out if we had to. We can just plug it right into this thing as well. It doesn't matter. But if you plug in negative 8, think about this. Let me give myself some room here. I'm going to erase this here. Okay? You're going to get 3 times 64 minus 9 over, here's a fun fact, whatever I get inside of these parentheses is being raised to the 2/3, which means square it and then take the cube root. And if you square it, it's always positive. So that denominator is always a positive number. No matter what I do, no matter what I plug in there, unless I plug in 0, I guess. But you can plug in negative 8. You're going to get negative 8 cubed minus plus 72. I don't know what that is, but it's going to be a positive number. So this ends up being a positive over a positive, which is positive, which means we're increasing there. A number in this interval here could be like negative 2. All right, so I'm checking negative 2 in that interval. If I plug negative 2 in, you can ask questions if you got them, gang. If I plug negative 2 in, to this, I'm checking to see if this is positive or negative. I'm going to get 3 times 4 minus 9, right? That's a positive number. That's 12 minus 9. Divided by, if I put negative 2 in that denominator, you can find out what it is, but again, it's being raised to the 2/3, which means we're squaring it, which means it's positive. So this is positive here, which is increasing. Okay? So, same process. It gets a little weird when the numbers are weird. But now I need a number in this interval. Negative 1 works. Okay? So if I drop negative 1 into my derivative, again, which is right here, I'm going to get 3 times 1 minus 9. But that's a negative number. Divide it by, and any to the 2/3 is positive still. So that's a negative, which means we're decreasing here. If I plug in the next interval, the number in there is positive 1. So that's something you need to know, that 1 is in that interval there, okay? When you plug in positive 1, you get the same thing. You get this right here, okay? Which is a negative over a positive, which is a negative, which means we are decreasing there. Okay? A number up here would be like 2. You can see the same thing's going to happen. You plug 2 in, you get 3 times 4 minus 9, that's positive, over a positive, which means we're increasing. And if you check this last interval as well, it's also positive. So this is probably the worst one we've seen so far. There's a lot going on there. But we're going to write like this. We are increasing, even though both of these are positive together, you wouldn't say we're increasing from negative infinity to negative root 3. You wouldn't count that. Well, the delta math might, which is weird. You you skip over that. If negative 3 is on the interval, you skip over it. So we're increasing from negative 3, or negative 3 to negative 3, and then from negative 3 to negative root 3. I'm just writing out the intervals in there. We're increasing again from root 3 to 3, and we're increasing again from 3 to infinity. That means we're decreasing from negative root 3 to 0, and from 0 to root 3. And just following our little rules here, just paying attention to what's going on here. We're going to find the relative mins and maxes. Let's just find the x value for these. So here's what this says. My function's increasing, increasing, decreasing. So at negative root 3, there's a max. Decreasing, decreasing, increasing, increasing. So there's a max and a min right there. Cool. So the relative min happens at positive root 3, and the relative max happens at negative root 3. All right. Any questions on that? There's a lot going on there. Most of the algebra that gets in the way. I can go over that again. Okie dokie. I'm going to do one more in this video. Let's check out number 4. Not the best. All right. Yo, number 4 is a little bit weird. If you want to follow along with me. Let me shrink this up here. All right. So first off, I think it makes sense for us to distribute this into here before we do this. All right, we got to derive it. But I think multiplying that in, which makes it x to the 5/3 minus 5x to the 2/3. And we're getting 5/3 there, kids, because this is x to the 1st, which is really 3/3. And when you distribute that, you add the exponents. Okay? But that just tells me that g prime of x is 5/3 x to the 2/3 minus 10/3, right? That's power rule, x to the negative 1/3. And this seems a little scary because we got this big old fraction. Here's my advice to you. You ready? Anytime, I get you killing. Anytime you have to find where something like this is 0, which is going to happen a lot for us, you want to get a common denominator. Okay, you want to put it all together. What's up, Kaylin? Is it about this or something different? Okay, let me finish this up on the out, okay? So our common denominator, you can see this, is going to be 3x to the 1/3. Okay, so that means I need to multiply this by x to the 1/3 and this by x to the 1/3. And that's nice because what it does is it makes it 5x over 3x to the 1/3, right? Minus 10 over 3x to the 1/3. And that's a pretty key step for us. But really, that's just one big fraction now, because that's why we got the common denominator. Okay, so that's our derivative there, which we would call as g. So we want to know where is it 0. That sets the top equal to 0. So that's nice. That's just when x is 2. We want to know when g prime is undefined. That's when we set the bottom equal to 0. But that just happens at 0. So the only thing going on my g prime number line is 0 and 2. So we're going to check a number down here, like negative 5. If you plug that in, you get negative minus 10, that's a negative, over negative 10. The cubed root of negative 10, not a great number, but it is negative. Okay, the cubed root of a negative number is a negative number, times 3 is negative, so it's negative over negative, which makes it positive, which means we are increasing. If you plug a number into here, like 1, you're going to get negative, right? 5 times 1, checking this, 5 times 1 minus 10, that's negative 5, over 3 times 1 to the 1/3, that's positive. So we're negative here, which means we are decreasing. And you check this interval, you're going to get positive, which means we're increasing. Okay, so the answer to this is that g is increasing from negative infinity to 0, unioned with 2 to infinity. It's decreasing from 0 to 2. We have a relative max then at x equals 0. Okay, because this is what this tells us, right? We go up, down, up. We have relative min at x equals 2. If we wanted to know the y values, we'd plug those back into the original, which we're not going to worry about.